Yes, Michael.
Okay.
All right.
Your pause concerned me a little there.
No problem. All right. Well, the next presentation we have here is from, by the way, our newest SCU member. So I just want to say thank you for being a part of us, Dr. Masters.
Absolutely.
While there are many hypotheses that have surfaced to explain UAP's origin, this is one of my favorites, is the most interesting as well. Dr. Masters, one of our most recent additions to SCU looks at the data, follows it, and makes a very compelling case that UAPs may be our descendants, somehow utilizing space-time in such a way that allows one to travel or move through to previous points in time. While the whole notion of time travel is contentious today, who knows what to expect in the future? And I'm all completely open as science continues to advance, and we might figure something out. But anyway, I just want to say that I'm looking forward to this. Dr. Michael Masters is a professor of biological anthropology at Montana Tech in Butte, Montana. He received a PhD in anthropology from the Ohio State University in 2009, where he specialized in human evolutionary anatomy, archaeology, and biomedicine. Dr. Masters spent the following decade developing a broad academic background that unites the field of anthropology, astronomy, astrobiology, and physics to examine the premises of that UFOs and aliens are simply our distant human descendants, returning from the future to study in their own hominin evolutionary past. His new book, Identified Flying Objects, a multidisciplinary scientific approach to the UFO phenomena, challenges readers to consider new possibilities while cultivating conversations about our ever-evolving understanding of time and time travel. The title of this is Time Travel, Hominin Evolution, and the UFO Phenomena. I want to welcome Dr. Masters, and take it away, sir.
All right. Yeah, thanks, Rich. I appreciate you having me, and for all the hard work you put into this conference. I know just how much work it was for you and the rest of the board. So it's great that this organization exists and that you're bringing together these scientists and industry leaders to have real informed conversations about this subject that's been taboo for so long. So I think this, among other things that are happening right now, really helps break down that stigma and relinquish some of the shame that surrounds the subject and has for decades, really. So much thanks again for having me here. So I recorded this presentation in March. Turns out I found out once COVID started that I don't do well with just sitting in a chair lecturing. I'm very kinesthetic. I have to move around. I tried that recording lectures for my classes and it just didn't work. So I recorded this a couple months ago. It was right before all of this media attention really started to surround the UFO subject. I kind of wished I had done it more recently so I could include some things that are happening now, but I mean, it was only 2 months ago, so it should be pretty relevant, but so much has been happening that it's definitely, you know, maybe we can jump into some of those things in the Q&A session that follows, I guess. But so yeah, this is a recording of a lecture, really just kind of summarizing the main points of this argument, what I refer to as the extratempestrial model. Like you said in the intro, just the idea that these beings and the craft that we see are the result of our distant human descendants, probably some of them even more proximate human descendants based on some of the descriptions of very human and human-like individuals that really don't differ from us in morphology that much, which I'll get into during the talk. So really, as an anthropologist, a biological anthropologist especially, who has focused on paleoanthropology, hominin evolutionary anatomy, I come at it primarily from that aspect. And you could argue that most of what we're seeing and what's been confirmed are these craft. And when we talk about the beings associated with them, obviously a little more tenuous. We don't have clear footage of that. But we have all of these different reports and all of these different descriptions and sightings where clearly this is the same phenomenon, that these beings are associated with these craft, and it's hard to really separate those and just talk about these machines without also acknowledging what thousands of people have seen and observed in association with them. So I acknowledge that that's a more tenuous aspect of the argument, but certainly something that should be considered as we move forward and trying to understand the holistic aspects of this phenomenon. So I'll stop rambling on and start rambling on in a recorded lecture, I guess. Just let me share my screen here, and I look forward to speaking with all of you after this, talking about the things discussed and things not discussed that I may have overlooked or missed. So one of the best aspects of science is to grow knowledge as individuals and collectively. So like Matt said at the end of his talk, I always look forward to being corrected on things and looking at things differently than I had before. It's really just a part of the process and what makes us scientists. So, all right, here we go.
We're not hearing your audio.
How's that? Can you hear it now?
No, we're not hearing your audio, Michael, at all.
Well, when we tested it before, it worked.
Yeah. Are you try
You have to,
muting?
Michael, you have to do a double share.
What's double share? I mean,
You share video, then you share audio.
okay. Let's see, share screen, share. And now how do you share the audio? Sorry, I didn't have to do this in the rehearsal.
Let's see if I can come up with an answer to that.
My apologies. This is why we rehearsed and everything worked fine in there. Let me try. All right, let me try doing this through.
Try turning off your audio once on the local thing once to see if that works. In other words, play it and then have your mute your mic or something. See if that does anything. Are you into share screen? Looks like he might have gone out and then he's coming back in or something. I don't see him now.
The dark matter got him, Rich.
Yeah, exactly. Yeah, exactly. There, he's back again. All right, so let's see what we got here. Still not hearing the voice.
Michael, mute your mic.
Terrestrial model. It's the hypothesis that these UFOs, UAVs, UAPs that are seen.
So I just shared my
currently
sound.
We're hearing it now.
Okay, good.
Prehistory
Sorry about
are
that.
simply
There
us
wasn't
from
an
the
option to
future.
do
Our
that in
distant
Whova, so
descendants
once
We're
I
not
opened it.
we're not seeing your video though.
Study their own hominin
Yeah,
evolutionary
let me
past.
see
So
what I can do
for the
about
purposes of this
that.
presentation, I'll mostly be looking at the anthropological side of things with
Yeah,
regard
we're
to
hearing your audio, but we're not seeing the video
evolution.
run at all.
In my book, Identified
Yeah.
Flying Objects, I look more at the aspects of time.
There we go.
There we go. Now
All right,
it's
let's try this again. Sorry for the
Go back to the
delay
beginning.
there. Should work this time. I think I left enough time, but with a short introduction that it should work. Let me know if there's any more
Hello,
technical
my name's
problems.
Dr. Michael Masters.
Yeah,
I'm
you
a
need to also mute your local mic as well.
at Montana Tech in Butte, Montana. Appreciate the Scientific Coalition of UAP Studies for having me, inviting me to give a presentation at this conference. It's unfortunate that we couldn't all be together for this event, but these are the times we live in, and I look forward to eventually meeting all of you at some point in the future. But this is an important question. Understanding this phenomenon is something that I feel is moving forward. We're moving in a good direction, and it's great that this organization exists and that we can all do this in one form or another to continue to carry the conversation forward. So thank you again for this opportunity. For my presentation today, I'm examining what I refer to as the extratempestrial model. It's the hypothesis that these UFOs, UAVs, UAPs that are seen currently and throughout human history and potentially prehistory are simply us from the future, our distant descendants coming back through time to visit and study their own hominin evolutionary past. So for the purposes of this presentation, I'll mostly be looking at the anthropological side of things with regard to biocultural evolution. In my book, Identified Flying Objects, I look more at the aspects of time, focus on astrobiology, astronomy, the physics of how this might actually happen based on longstanding research within the field of physics, but also other fields that investigate time and how backward time travel might actually work. So I feel like all of these things are important and an important part of the argument, but for the purposes of this talk, I'll mostly just be focusing on the biological, evolutionary, anthropological side of things. As scientists, we have an important role to play in bringing more credibility to this conversation, bringing the skills and knowledge that we possess to help lend credence to a real examination of what's happening with regard to the UFO UAP phenomenon. There seems to be a divide currently between those who really talk about this almost as a religion or a belief system, where there's rampant speculation that deviates from a lot of the evidence or the observations that can be made and the things that can be studied with regard to what's taking place. And I feel like this tends to drive a wedge to some extent. It's almost like there's two camps. And after publishing my first book on the subject in 2019, I've sort of gotten to know a lot of people involved in research in this area. And there are quite a number of people doing valid scientific research with regard to this question, and that's really great to see. Again, there's also sort of the belief side of things where it's more of a religious ideology, and it doesn't matter what actually can and cannot be tested or what evidence we have in support of different notions. It's more just a belief system, and that's fine too. If it's something that adds to someone's life, then they should absolutely be able to treat it in whatever way they want. But I feel like the purpose of the SCU and many of us who are investigating these questions seriously tend to take a more realistic look at what we can know, what we can't know, and try to evaluate the reality of this phenomenon in the context of those things. So it's an important thing to focus on, it's important to be aware of, and I feel like everyone involved in this conference, I'm sure, is. There's a lot that can be gained, though, from bridging this divide and working together. The ufologists have a deep knowledge of this phenomenon and what's been happening throughout the ages, and very good historical context that can add a lot to the discussion and inform a lot of those that don't necessarily have the time or energy or ability to really look into it in that way. So we can draw a lot from the research of others. And I feel like the contribution of the ufologists is extremely important for that purpose. We also have journalists who have contributed tremendously to not just an understanding of what's going on, but getting this out into the public eye, especially since 2017 with the New York Times article and subsequent articles and the Tic Tac UFO, the confirmed videos that the Department of Defense just legitimized last April of 2020. All of these things are kind of coming together to lend more validity and decrease the stigma associated with this question of UFOs, which has been intentionally stigmatized really since the late 1940s. So working with military, working with police, the general public, abductees, contactees, I feel like any information should be critically considered and incorporated to help us continue to grow understanding of what's taking place. Obviously, the physical sciences, the social sciences, psychology, economics, political science, there's a lot that we'll need to know and need to understand with regard to what might happen with full disclosure, with first contact, with the breaking open of this question and a deep-rooted, broad-based understanding of what's taking place. So it's really not just about the physics of these craft or about what we might be able to garner from the descriptions of their physiology in an evolutionary context, but really all of the scientific disciplines have something to contribute. And I think we should all be working together, and there seems to be progress in this area where we seem to be moving in that direction. I've been to conferences to give talks and have met a lot of people who are still a little shy about talking about it openly, or they're afraid of retribution from their institution, their department, but who are really interested in this and have something to contribute. And I feel like if we continue to challenge the stigma that's been manufactured over the last 70, 80 years to keep us from discussing this, that great strides can be made. And I'm happy to say that with regard to my own, anecdotally speaking, my own experience in this regard, it's been quite positive, and I've been happy to see that. I really didn't know what it would be like when I published this book. I have a record of publishing and writing grants and receiving grants and working with students, mentorship, all of the things we do in a university setting. So I kind of jeopardized that. I put that on the line a little bit in coming out with this book, but it's been a tremendously positive response. The chair of my department, the vice chancellor, the dean, the chancellor of the entire university, we're all very excited about this. The honors department asked me to teach a class centered on my book and about the UFO phenomenon more broadly. So at one of the top science and engineering schools in the Pacific Northwest, it's great to see that they're taking this seriously and that there's encouragement and even offering to have classes dedicated to this subject. And I feel like that's a sign of progress. Again, it's anecdotal, but the more we continue to talk about this as a normal thing, the more we'll continue to normalize it. And I feel like this conference and the people that are contributing to it and others much more broadly are working in that direction. So as I mentioned, I'm mostly going to focus on what I refer to as the extratempestrial model. Basically, I just took the word extraterrestrial, which in the middle has the Latin root ter, meaning earth, so outside of earth, and replaced it with the Latin word for time, so meaning outside of time. That way, ET is still the same acronym, and we can still keep the same connection to the overall idea of something from somewhere or someone else, but make a term that's more indicative of what I think is the origin of these craft and the individuals piloting them, which is from outside of our time. potentially right here on Earth, just in a future time, and not from a different planet, though that could obviously be a part of the situation as well. I don't see this as mutually exclusive, but rather as just another interpretation that I feel should be considered. So again, the basic idea is that these UFOs, UAPs, are the time machines themselves, and that they're being piloted by our distant human descendants who are coming back through time to visit and study their own evolutionary past. And we, as more primitive members of that past, confuse them for something else. And it makes sense why this would happen if we see them coming down from the sky and we don't have a deep-rooted understanding of time in any sort of physical sense. It's an emergent phenomenon. We don't really even understand what is at the root of this phenomenon. But if we see them coming down from the heavens above, we would naturally interpret them as being from those stars that we also see above. So it's intuitive. The extraterrestrial hypothesis is intuitive, but we should also consider other aspects of these craft, and especially those who are ubiquitously seen piloting them in the context of other models. So I feel like this extratempestrial model is one that should be considered, especially because it is testable. The extraterrestrial hypothesis isn't a testable, falsifiable theory, but if we continue to exist, we would eventually, under this extratempestrial model, become the ones piloting this craft, and that would answer the question. It will have been tested, it will have been falsified if we get to the point where we become them. Even if we destroy ourselves, humans are annihilated, this has still been tested. It's been falsified. There's no one left to show that this has been falsified, but it has been so. And I think that's an important aspect of this model, and something that lends it more to scientific inquiry than a number of others that have been proposed. So if we look at our evolutionary history, it's been relatively unique in the context of the fact that we have culture. It's not just our physical form that changes, but we also have this interesting and unique relationship between our biology and culture. We have our biology contribute to our cultural implements, and our culture contributes to our biology at the same time. And there's a number of changes that have taken place throughout this period, an acceleration, a sort of feedback loop, which I'll talk about here in a second, where we see a number of changes that characterize hominin evolution throughout this long 6 to 8 million year period. And if this continues into the future, we would expect to look very similar to what is most commonly described in instances of close encounters, where you have big-headed, big-eyed, small-faced, diminutive ears and mouth, slender bodies. A lot of these would be expected with the continuation of the same long-term evolutionary trends in hominin history. So in a sense, we could potentially connect the dots between our past, our current state, and this perceived future state if these are in fact our distant human descendants. So what is a hominin? A hominin just refers to any upright walking modern human or human ancestor. So we became bipedal beginning 6 to 8 million years ago. In fact, bipedalism is the trait that defines the hominin lineage. So as we stood upright, there were a number of other characteristics that changed in association with that. But just standing upright unto itself ushered in a number of evolutionary shifts that went into making us highly unique among other mammals, among all life forms on Earth, but especially in comparison to our closest primate relatives. So we can see here that this split, this bifurcation between the line that led to us as modern humans and that which led to what is the common chimpanzee, Pan troglodyte, and Pan paniscus, that's when this break took place between 6 and 8 million years ago. We stood upright, they remained quadrupedal, their environment stayed more or less the same, still lived in a relatively dense rainforest environment, Over time, our environment shifted, and that helped contribute to a number of the changes that took place, largely in East Africa and South Africa, over the course of the first 2 to 3 million years since we did begin to walk bipedally. So the environment had a lot to do with it. Just simply standing upright and walking bipedally in general ushered in a number of unique changes. And one of the most important among these is that as we stand upright, we had to rotate our heads downward so we could see where we were going. If we look at an early hominin or a chimpanzee skull, the foramen magnum, the big hole at the back of the skull where the spinal column passes, is more posteriorly located. And that makes sense because if you're walking quadrupedally, you want that orientation of your eyes to be along the horizon so you can see where you're going. However, as we stood upright, now our visual plane is oriented toward the sky, which isn't beneficial for walking and not running into things. So our heads had to rotate down. And as that happened, it created a flexing of our basicranium. So if we look at the inside of the skull, we have the anterior, the middle, and the posterior basicranium. And as the foramen magnum shifted down and forward so that we could rotate our heads forward and see where we're going, the face also shrunk back. So we have this rotation of the face down and backward, more posterior, and we also have the foramen magnum moving down and more anteriorly toward the front. A lot of times this is referred to as the slinky hypothesis because it's similar to what we would see, and you can see very clearly with the slinky. If we imagine the back of it as the foramen magnum, and that moves down and forward, and then we have the facial structure moving posteriorly and inferiorly as well. As the entire basicranium flex, we get this more bulbous, rounded area along the top of the skull. So a lot of our bigger brains throughout much of our evolutionary history may have just been because of this craniobasal flexion, which resulted from standing upright. So we can see this very clearly in looking at other hominins, and especially those within our own lineage, where with the Australopithecines, they have still these low sloping foreheads, a more posteriorly located foramen magnum. They still have more prognathic faces, meaning they stick out more. But as the basicranium flexed, as that foramen magnum comes forward, and as the face becomes reduced and retracted throughout our evolutionary history, even now, even into more recent stages of hominin evolution, that basicranial flexion opens up more space in the neurocranium for a larger brain to grow. And there's other things that contributed to this as well. But a lot of our uniqueness as a species has to do with this one dominant trend throughout human evolution. So if we look at other hominins, here we can see in the pink squares, anatomically modern Homo sapiens sapiens, who are characterized by not just larger brains, but what we call neurocranial globularity. And this is something that defines our unique species, Homo sapiens sapiens, our subspecies as well, where our brains aren't just bigger, but they've expanded mediolaterally. We have these big, bulbous, sort of bobble-headed characteristics. Brain expands mediolaterally, it moves forward out over the eyes in association with continued facial reduction. If we look at earlier members of our own genus Homo, you can see that they have, as indicated by these blue stars, that same sort of more primitive trait, larger faces, lower sloping forehead, and not as much brain development in general. If we go back to the Australopithecines, some of the earlier members of our clade, you can see far more facial prognathism, not very much brain development. Obviously with other apes, orangutans, chimps, gorillas, you can see that even more. They have big prognathic faces, big teeth, large fangs. In fact, their canines are much bigger by comparison. and much smaller cranial capacity, only about 400 cubic centimeters compared to ours, which is 3 times that, upwards of 1,600 cubic centimeters. So this main shift really characterizes hominin craniofacial evolution, which again is largely associated with us standing upright and walking bipedally. So if we look at a CT scan of one of our more recent human ancestors, Homo ergaster, also known as Homo erectus, you can see that we already have a larger brain. We start to see the development of a forehead. Our parietal lobes are expanding, but our brains still sit back behind the eyes. In modern humans, however, we're actually the only mammal who has this cerebral craniofacial configuration in which our brains have developed, and especially the frontal cortex of the brain, and move forward to the extent that it sits directly on top of the eyes. And a lot of my more mainstream non-UFO research focuses on what effect that might have on visual acuity, whether astigmatism, juvenile onset myopia could be associated with just having this close proximity of not just the brain sitting above the eyes, but also the mid and lower facial anatomy retracting backward. Does it pinch the eye? Does it circumscribe the eye and the other ocular tissues as a result of the runaway brain, our big brains growing to the extent that it imposes itself on the ocular cavity? But from a lateral radiograph, we can see just how much this trade-off's taken place, especially in comparison with the chimpanzee, who have that more ancestral characteristic where the brain sits back behind the eyes. The eye is roughly the same size as our own, but the orbit's much bigger and is occupied by ocular fat and obviously the ocular muscles as well. But you can really see in this lateral radiograph comparison just how much from a more primitive ape-like ancestor our craniofacial anatomy has evolved. And a lot of this, importantly, has happened relatively recently. Throughout much of hominin evolution, it was our postcranial anatomy from the neck down that was essentially adjusting to bipedalism, but our craniofacial anatomy stayed relatively primitive. It's only in the last 500 to 800,000 years, and especially since the origins of our own subspecies, Homo sapiens sapiens, that we really start to see this acceleration in the growth and expansion of our brains, getting that more globular characteristic specifically. So a lot of this that makes us human, that makes us, as we would appear alien to Homo erectus or the Neanderthals, we would have these same characteristics. And I often use this as an analogy with this extratempestrial model. If we were to go back 200 years into the past, we would look more or less the same as our ancestors at that time. There'd be slight differences. Most would just be cultural, technological differences. They would see that we're operating highly sophisticated machinery, but we would look the same physiologically. If we go back and pick up the earliest members of our species, Homo sapiens, around 200,000 years ago, we would look quite different. But if we go back 1.5 million years ago and abduct Homo erectus and do a bunch of biomedical examinations on them, now we're the ones with the big round heads, the big eyes, the small faces, the relative hairlessness, all of these same things that are described in so many contactee and abductee reports. So it is important to focus on these aspects of our craniofacial evolution, because if we do fast forward those into the future, we would expect to have the same characteristics that are so commonly described in these reports of close encounters. But it's not just our physiology and our morphological shifts, but also the other things that go along with it. By standing upright, yes, it definitely modified many aspects of our physiological form, but it also allowed us to use our hands. And that's an often overlooked aspect of our uniqueness and of bipedalism specifically, is that we now have these things that used to be burdened with locomotion, having to move our bodies, that can now be used to make all kinds of new and important things that contribute to our livelihood and our success as a species. So some of the most notable are stone tools, beginning about 3 to 3.3 million years ago, fire about 1.8 million years ago. Agriculture is definitely on that list, and all of these things that we've made since then. In fact, the tools we have today are the direct descendants of these first stone tools. We have descent with modification in our toolkit and our culture in the same way that we do with our physical form. It also follows this same descent with modification aspect in an evolutionary sense. So as I mentioned previously, this also initiated a brain behavior feedback loop where our culture started to contribute to our physiology. We started to change in many ways that we hadn't before the advent of culture. Some notable examples are with the advent of animal husbandry and beginning to utilize milk products more often. We selected for the gene that codes for the production of lactase, which breaks down lactose in these dairy products and milk. And that allowed us to continue making that later in life. So we start to be able to consume milk into adulthood, which isn't normal. Most mammals, that gene shuts off and they stop producing lactase, but humans have continued to do that. Another good example is with stone tools and with fire. Once we started to cut our food, once we started to be able to process it, once we started to be able to cook meat especially, it began that process of breaking it down, making it easier to chew, allowed our teeth to get smaller to get out of the way so that our brains could continue to grow and continue to move forward, since the rest of craniofacial development and an ontological growth and development context happens after brain growth has ceased. So it allows our brains to grow bigger and longer because we don't have to sustain the masticatory muscles, the chewing apparatus, and the big teeth that we had prior to using stone tools to cut meat and fire to cook meat. So this is what we refer to as biocultural evolution, and it's really unique to hominins. No other species alive on this planet has this same relationship between their physical form and the culture that allows them to adapt and to persist and survive in so many different environments. So it really is a unique aspect of hominins, and again, largely comes back to our bipedalism and the free use of our hands. As I mentioned, this has also been an acceleration in recent times, not just in the rate at which our brains change shape and change the entire configuration of our craniofacial anatomy, but also in our technology. This feedback loop continues to accelerate, where we have new technology coming out all the time. It's hard for people within one generation to even keep up with it. A lot of older people just give up and say, I don't care about computers, I'm not going to use one. I've had a lot of friends. One of my best friends died recently. He was 93, never used a computer in his life. He just got off that highway of technological progress and said, I'm not going to be a part of it. So it's happening faster and faster, and if that continues to be the case, and we continue to advance material science and engineering and our understanding of the physical world and the laws of physics, quantum mechanics, it's very possible that we could eventually even develop the capability to achieve backward time travel. So, not to harp too much on this aspect of bipedalism, but it is important for understanding us as a species. But it's also important for understanding the likelihood that we may get another bipedal humanoid form evolving on a different planet. And that's mostly because it's extremely rare here. It's something that really only we do habitually. We're the only habitual bipedal primate, but it's also rare among all mammals. Some will sit up for periods of time, stand up. Chimpanzees will walk bipedally for short periods, but we're the only ones that do it full time. So its rarity here on Earth, with gravity of only 9.8 meters per second squared, the acceleration that pulls us down, if it's that rare here, we would expect it to be even more rare on other planets with more gravity. And based on data that's come out from the Planetary Habitability Laboratory at the University of Puerto Rico in Arecibo, where unfortunately the Arecibo Observatory just bit the dust December 1st, I think it was, when it finally collapsed. But there's a lot of good data that's obtained and a lot of good studies that are being done at that university. And one of which shows us that only 46 of the 2023 exoplanets, as of 2016, when this data was published, 2.27% of them had a mass equal to or less than that of Earth, which means that the vast majority of exoplanets that have been studied in and around us in our galactic neighborhood are bigger than Earth. And if bipedalism is so difficult here, with a relatively small planet, it's likely to be even more problematic on exoplanets that have more mass, more gravity than what we see here on our own home planet of Earth. Even humans, even though we've been bipedal for 6 to as much as 8 million years, we still suffer from a number of problems. The former director of the Natural History Museum in Cleveland, Ohio, where I did a lot of my dissertation research as an Ohio boy, published a paper back in 2005 noting a number of negative aspects of bipedalism, what we refer to as evolutionary trade-offs. There's this misconception that evolution is always leading us to bigger and better things. Things are always getting more progressive and or working things out. But in most cases, when something beneficial arises, it comes at the expense of something else. And this is what we refer to as an evolutionary trade-off. And it's certainly been the case with bipedalism, having free use of our hands, having bigger, more complex, better wired brains that allow us to do very interesting and complex things as a species, has come at the expense of a number of uncomfortable things. And obviously the benefits have outweighed the costs, or we wouldn't still be walking bipedally. But there are some negative things that are certainly trade-offs to some extent. As indicated on the screen, a lot of the neck, back problems, hip problems, ankle problems, just things associated with this force pushing down on our skeletal anatomy. Complicated births, we suffer from something known as the big head, small hole problem. We have a very small birth canal relative to the size of our heads, and we come out early as a way of getting around this. We also have an extra suture in the frontal bone called the metopic suture. We have a fontanelle that allows us to become more cone-headed when we come through the birth canal. And more recently, we have cesarean sections, which have relaxed this selective pressure to some extent, at least in Western societies where people, women have access to this technology. So it's possible that this could be the thing that allows our brains to get even bigger, even earlier. But it does benefit us to have most of our cerebral growth outside of the uterine environment because we rely so much on culture. So even though we come out more altricial, more helpless, especially relative to other mammals that they give birth and the babies just start running around on the Serengeti, for example, we come out in a very underdeveloped state, largely so we can get out in the first place, but also so we can grow our brains in a very stimulus-rich environment. So all of these things, again, are somewhat detrimental, but they're not going to kill us. So they don't really affect us in an evolutionary sense, but we have certainly traded bipedalism for some other things. So in addition to the gravity aspects of it, the uncomfortable aspects, how rare it is here on our own planet, if we were to evolve on something larger than Earth, we would expect our physiology to be much different. Not just to be more muscular. There's actually a great show, one of the best science fiction shows on TV right now called The Expanse, in my opinion. Do a good job of highlighting how people not evolving on, but just growing up on planets with different gravity are affected in different ways. Mars, asteroid people don't fare as well on the gravity of Earth, but outside of Earth, on most of these exoplanets, which are much, much bigger, we'd be expected to probably not even have two legs. We wouldn't expect bipedalism on these planets. And it's not just me speculating about that, but Dr. Bill Sellers at the University of Manchester in the United Kingdom did a pretty complex computer simulation in concert with a genetic algorithm, as he called it, where he wanted to see what the most efficient form of locomotion would be on super planets or super Earths or exoplanets with hypergravity. Even ones as small as Kepler 62f, which has a radius of 1.41 that of Earth, found that the results of his study that you would have an organism that would be a large, low to the ground, showed that they were sort of a grazer that had 8 legs. So you would need more mass and you would need more to prop up and to move an organism that evolved on even something with slightly more gravity than what we see here on Earth. So in looking at this physiological, biomechanical analysis, we see that even here on Earth, we go a little bit bigger, a little more gravity, and we're going to have a very different physical form evolve on those, a non-humanoid, non-hominin form specifically. There's a number of other problems too associated with any life form evolving on a planet larger than our own. The air, the atmospheric pressure would be much higher. You would have a different boiling and freezing point for water, which, while that may not be a huge factor, it could certainly be one of many things that altered the path of life, in addition to the chemistry, how far it was from its own sun, whether it's in a binary star system. Any number of things could contribute to a very different evolutionary pathway than what we saw with our own history here on this planet. Also importantly, if it was more massive, it might have a solid core. We have this fluid liquid iron core that is what contributes to our magnetic field. We didn't have that magnetic field on a larger planet with a solid core. There would be a lot of problems with radiation, and it may not even be possible for life to arise in the first place as a result of that constant bombardment of ultraviolet radiation. And then lastly, and perhaps most importantly, as far as negative effects of living on a larger planet, it would attract more asteroid and comet impacts. So you might have to worry more about your entire civilization being destroyed, or things where the large percentage of the biomass is just wiped out at any given time, such as what we saw 65 million years ago with the asteroid that largely contributed to most of the dinosaurs being wiped out, and what we currently see with Jupiter. It attracts far more asteroid bombardments and actually helps us out. It's one of the things that makes Earth and our position in this specific solar system somewhat unique, is that we happen to have this big brother, big sister that's sucking up all of the asteroids for us, that helps protect us from all of these random rocks floating around in space. And then if we did want to leave, if we did want to escape Earth, it would be harder to do so because of that extra gravity. We'd have to have a different propulsion system that would allow us to actually get not just us, but that machine, whatever it was, and whatever that propulsion system and the fuel necessary to allow it to leave Earth. It would take much more energy in order to leave a planet that had higher gravity than what we have here on Earth. So there's a lot of issues associated with not just how we would look and the low probability that we would get a human or even a human-like creature evolve on a separate planet that could find us in the vastness of space, that could come here and visit us so regularly, seemingly, and throughout such a long period of time, as indicated by the longevity of this phenomenon. It just doesn't seem likely that that would happen given all of these limitations with astronomy and astrobiology. Another notable trend that is somewhat unique to us as a species is that we have a high level of neoteny, or paedomorphosis, where we retain juvenilized characteristics into adulthood. So put another way, when we grow up and reach maturity, we retain more of the traits of our ancestral juveniles. We keep those younger, more youthful traits even once we reach sexual maturity as adults. And this is something that defines our hominin lineage. It's been something that's happened really throughout the long history of hominins on this planet. You can see from this early representation that one of the main things that happens as we become more paedomorphic is that we start to get more baby-like characteristics, the big head, the big eyes, the small faces, the cute characteristics, the things that make babies and puppies and kittens so cute is they have these big, adorable characteristics. And we start to have more of those being retained into adulthood as a species as a result of this trend in neoteny. And if we look at this in the context of not just our postcranial, but also our cranial morphology, we see it even more so, even in looking at an infant chimpanzee, bonobo chimpanzee, Panpaniscus specifically, compared to an older adult, that they have more of these juvenilized traits. We look much more like that infant chimpanzee than we do the adult chimpanzee, because we retain more of those traits. And we have, and this has continued to occur even into more recent human evolution. Other major trends, especially since the advent of agriculture, we have started this process of self-domestication. A lot of people don't realize that in addition to domesticating all of these other animals, we've also domesticated ourselves. And there's a number of things that happen in association with that. We become more nice to each other, essentially, if you can believe that. Humans are still a very warring species, a lot of violence and conflict, but relative to pre-agricultural groups, there has been selection for pro-social behaviors. We've become more docile. We also, not just us, but any animal species that undergoes this domestication process also loses pigmentation in their skin. Foxes, wild dogs begin to bark, their tails get more saggy, their ears get saggy. There's a number of things that take place in association with this process. One other notable trait for us specifically is what's known as craniofacial feminization. And what we see is that we start to not just exhibit more characteristics of our ancestral youth, but also more traits of females. And there's a number of things that help us differentiate between a male and female skull. If I find a skeleton in the woods, I can almost instantly tell you what its sex is, what its general age is, what its ancestral heritage is, what part of the world it may have come from, what we used to refer to as race. So as we shift more toward becoming domesticated, we also see an increase in craniofacial feminization. And as part of the research for my book, I did a geometric morphometric analysis of a number of human skulls. And as part of this analysis, you factor out size. There's an obvious size difference between males and females, and that contributes to a large part of the variation. But once you factor out size, and you're just looking at shape, we can see that as we move from an extreme male shape toward the average of males and females, and then more toward an extreme female shape, which is likely the direction that we have been going and will continue to go, we can see that we get almost alien-like characteristics. And this doesn't predict anything. It's not showing that this is what we will look like, but it is important to consider in the context of this more recent trend. And in fact, if we look at the lateral view, you can see that this extreme male shape has many of those ancestral traits: the prognathic, lower facial, mid-facial anatomy, low, sloping, dolichocephalic, and elongated head. And as we get to the average of male, female, more modern form, obviously. And then if we project that even more forward to the extreme female shape, now we can see that we have more parietal expansion, even more frontated neurocranium, more retracted face. And what's interesting, I also made a video representation of this, is that if we look at the eye orbit specifically, you can see that this upper part of the eye orbit goes from kind of being low and rectangular in shape to being sort of wrapping around, and that superior lateral side of the eye orbit starts to kind of move around the head a little bit more, and also up and to the outside a little bit. And many of these reports of close encounters with these alien beings, they're described as having larger eyes and sort of wrap around, oftentimes oriental looking eyes. So if this is an aspect of our evolutionary future, if we are to become more craniofacially feminized, this may help explain not just the neurocranial, but also the ocular aspects of that future form. So what about the eye specifically? Unfortunately, the eye doesn't preserve in the fossil record. The hard tissue anatomy of our eye orbits and the rest of our craniofacial anatomy typically does. It's a somewhat fragile area of our skull, so it does succumb to post-mortem destruction in a lot of cases. But we do have pretty good representation of the midfacial anatomy in the hominin paleoanthropological records. So what we see are a number of trends with regard to an increase and decrease and a change in shape of the orbit throughout our evolutionary history. But the eye itself, even though we can't measure it directly, there is some indication that it has been getting larger and will continue to. And that's partly because of this pleiotropic gene relationship between the eye and the brain. And pleiotropy just refers to when you have the same gene or set of genes controlling the development of different traits. So if we have the same genes giving us bigger, wider, more frontated brains, we would also expect that the eye is getting larger in association with that increase in our cerebral anatomy, simply because they're being controlled by the same genes. In addition to that, there's the simple fact that the eye grows out of the brain. The earliest stages of fetal ontogeny, the optic vesicle, grows directly out of the forebrain. Again, demonstrating that they're more or less one and the same. We would expect this pleiotropic relationship simply because the eye grows from the brain. So they maintain that same relationship throughout growth and development, which would have a negative impact on vision, coming back to a more mainstream research. If the brain is able to bend and fold within the confines of the calvarium, within the skull, but the eye can't be accommodated by an increase in orbital cavity simply because the brain sits right on top of it and the face moves back, we would expect to see the same types of things we see in juvenile onset myopia, where you have a larger, more elongated eye and it focuses light in front of the retina. But even though we can't know whether or not the eye has gotten larger in a paleoanthropological context, we can infer from what we see in the brain and the size of the cranial cavity that the brain and the eye have likely gotten bigger throughout time. We do know that we have lost body hair. We can see this very clearly in relation to our closest living primate relatives, the hominoids, who don't have less hair per se. They have the same density of hair follicles, but the hair has gotten much smaller. And there's a number of theories as to why that is. A lot of the main theories have to do with hunting. that we evolved to chase our prey until they overheated and we didn't, and then we just smack them on the head with a rock and go feast for a little while. But we have continued to become more hairless, relatively speaking, over time. It's also been a dominant trend toward increased gene flow, which could eventually, especially since European colonialism, beginning around 500 years ago, lead to genetic homogenization. We used to have all of these isolated gene pools, and there was some flow between them, which is one of the things that contributed to new gene variants within each of these isolated interbreeding groups. But if we do continue this trend toward global interbreeding, simply because we're traveling around and making babies with each other, we would eventually reach a point of global incest. So in the context of the constant sampling of gametes that we see in all of these different UFO encounters and abduction reports, may help explain this, that they're going back in time to sample new gene variants from haplogroups and haplotypes that didn't make it into the future. So it might be the only place to get novel gene variants, since we don't have other groups to take them from anymore, simply to go back in time and get those from other populations. We also see a diminishment in birth rates. That could help contribute to this problem, where we see a population decline. We already see a number of industrialized countries drop below the replacement rate. The US isn't quite there, but we're sort of teetering on the edge. And well, that is certainly a good thing in some capacities. There's also evidence that, especially from an economic standpoint, that diminished birth rates could have a negative impact. We've certainly gotten smarter. That's occurred in association with the increase and reorganization of our brains throughout Hominin Evolution. And that obviously has contributed to an acceleration in our technology. We have more complex technology than we have in the past. And again, we can see that from the very earliest stone tools on through to the descendants of those stone tools and all of our smartphones and computers and cars and things like that. And as I mentioned earlier, if that does continue into the future, we may even potentially unravel the mysteries of time and be able to build a device that allows us as physical entities to travel backward in time. So taken together, I somewhat jokingly refer to this as astrophysical anthropology, taking astrophysics and astrobiology, combining it with physical anthropology, which is my field. If we can look at all of these things together in the context of the UFO phenomenon, and the more tenuous part of it, arguably the contactee and abductee accounts, it's somewhat different to have this craft flying around being observed by highly trained pilots and radar operators. Once we start talking about the beings inside, it's obviously a little more tenuous. But if we can take seriously the reports of abductees and contactees, they almost ubiquitously describe things that are hominin. There are exceptions to that, a certain percentage based on the Dr. Edgar Mitchell Foundation's FREE study. Only about 5% would fall into the category of reptilian or insectoid. The vast majority are described as human. Not just humanoid or human-like, but human, in the same way that we are, with our very human characteristics. The next category after that, based on their survey of over 3,000 contactees, are the grays, the tall grays, the short grays, which are sort of the archetypal alien, so to speak. But even in looking at these forms, the human, humanoid, gray varieties, they're still bipedal. They are tetrapods, meaning they have 4 limbs, which is something that goes back 400 million years on this planet. Most everything outside of certain insects and fish are tetrapods. It's become the dominant form. And again, on another planet, you could have more legs, and that would be something that everything might have there. We're also pentadactyl. We have 5 digits on each of those limbs, which is also something described of these alien beings. We are bipedal and arguably will be in the future. There's no reason why that would change, since it's something that dominates the last 6 million years of our evolution. These alien beings are also reported to be bipedal in almost every case I've ever come across. And again, like I've said 100 times, if in these reports they were describing some 20-legged squid creature, I never would have written this book. I never would have investigated this in any capacity. But the fact that they're always, or almost always, considered to be human and described in such human terms indicates that we should consider their humanness, and especially in a time travel capacity. Big round heads may indicate the persistence of cranioglobularity. As I described, it's not just bigger brains, but also the shape of the brain, how that changes. The smaller faces, which again, as I described earlier, is that trade-off. We've traded big faces with big chewing muscles and big teeth for a larger brain. We have thinner cranial bones. We have smaller muscles that attach lower down. Everything's basically gotten out of the way of our runaway brain throughout our evolutionary history. 2 large eyes, as described, again, that could be an aspect of pleiotropy and an increase in brain size, which would be expected to also increase eye size. Childlike features, a lot of cases, these extratempestrials are described as being very childlike. In fact, I believe Travis Walton in his book described them as being overgrown fetuses. So that's a very common description, especially of the grays, that they're described as little kids running around, kind of the busybodies doing a lot of things. Importantly, there's some indication of cultural continuity. In almost every case, they're described as communicating with the abducted in their mother tongue, in their indigenous native language. Interestingly, some have a better mastery of the language. In the Betty and Barney Hill case, Betty recalls having some individuals that almost acted as ambassadors that were communicating with her, but then once the examiner, as she called him, came in, he didn't speak quite as well. So there could even be some specialization that takes place. Linguists who have the role of interacting with those that they capture and obviously telling them, be calm, we won't harm you, which happens in almost every case. Technology advanced beyond our own. We know we're here. We know we have a long evolutionary history on this planet that also is characterized by an increase, an acceleration in the complexity of our technology and in our culture. So if that continues into the future, we would expect to have even more sophisticated machinery that would seem magical or alien to us, even though it's derived from the same things that we use now. So some of the variation that is described could be a result of temporal ancestry, even potentially with these reptile or insect-like beings. They could potentially come from a very distant point in our evolutionary future where we don't even recognize ourselves as human anymore. It could potentially even be a post-human society where actual reptiles or insects replaced us and came back through time to study their own much deeper past. It's hard to say, but in the same way that we see geographic, racial differences, ancestral differences today, we would expect to see differences among people coming back from different time periods in the same way I described earlier, with ones that are 200 years to our future versus 10,000 years or 100,000 years. So the variation described by contactees could simply be an aspect of which time period these individuals that they see happen to have come back from. Lastly, some other things to keep in mind. If I had time travel technology at my disposal as a paleoanthropologist, I would be doing exactly what these individuals are described doing. I'd be taking hair samples, fingernail trimmings, toenail trimmings, examining the mouth, the skin, the eyes, taking fecal samples. You can learn quite a lot from fecal matter. In fact, that's how we know that Neanderthals consumed about 7,000 calories per day, and mostly meat, because we found fecal matter of theirs that we could break down and look at the molecular composition of. So that indicates, again, some sort of cross-cultural continuity, or indicates some sort of research aspect to at least part of the abduction phenomenon. It could also be tourism. That may be some aspect of it. The Foo Fighters that were so commonly reported during World War II and around other major events could be people from the future who paid some money to go back in time and see a part of the historical or prehistoric past that they're very interested in, to help answer questions, things that have been misinterpreted or misrepresented over time. We can get actual answers to those questions with the ability to go back and investigate for ourselves. And it may even be something that helps drive forward the technological development of backward time travel machinery, if the private sector is involved in the same way that SpaceX and Virgin Atlantic are moving forward with space flight technology, because there's money to be made, there's profit potential in taking people into space. If there's profit potential associated with taking people through time, it might not just be governments developing this technology. It could be individuals, innovators in the private sector who are trying to make a buck from taking people back in time. As I mentioned, it's improbable that we would have, at least in our celestial neighborhood, any humanoid or human-like being develop, not just on another planet, not just close to us, but at the same time, so as to be so similar to us in technology, but just slightly more advanced than us, let alone to find us in all of the other areas of space within our galaxy where there could be other civilizations, to know our language, to be able to come here and interact with us in such interesting ways, or that they would come from all the way across the galaxy, or even from a star 20 light years away. If they had the technology to do so, then why not introduce themselves? Doesn't really make sense why they would schlep all the way across the galaxy and not get out and say hello if they had come all that way. Hi, we're from this planet and this star system. Nice to meet you. In the context of time travel, though, it does make sense. If they know we're here already because they came from us, even though there aren't time paradoxes per se, at least in the context of the block universe model, it's still, for a population that didn't yet have the ability to understand who they were and what they were doing here, could potentially lead to a lot of negative impacts, at least until we got to the point where we did understand who they were. And if there aren't paradoxes, then we could potentially interact, possibly live amongst each other. They could pick us up and take us around. We don't have to wait until we become the ones doing this. We could potentially know at any point when they wanted us to know. And I obviously am hopeful that that happens in my lifetime, but who knows? So for more information about much more than I'm able to cover in an hour-long lecture, the book is called Identified Flying Objects, a Multidisciplinary Scientific Approach to the UFO Phenomenon. Again, it looks more at the physics, the astrobiology, the astronomy, in addition to the anthropological side of things. I also have social media website that gives more information about the book, and a new book coming out later this year, if all goes to plan, called The Extratempestrial Model. It's a deeper dive into this question and draws from some well-known and some lesser-known case studies to sort of examine those in the context of this time travel model, but also interdimensionality, the extraterrestrial hypothesis, the simulation hypothesis, and others. So I appreciate the SCU having me to give this talk and to continue to share in dialogue with my peers and especially my scientific colleagues. And I hope that we're able to continue to move this conversation forward, and hopefully to even be able to meet all of you in person at some point in the post-pandemic future. Thank you again.
Hey, Rich. Can you hear me?
Yes.
I think I'm going to jump back over out of Zoom and onto Huva, if that's all right.
Yep, that's fine.
Cool. I'll be back in a sec. All right.
You're back.
And I'm back.
Okay, well, excellent job. Thank you very much for that presentation. We'll head to the question and answers while we have time here. The evolution of techno-capable exoplanet life is likely to have to go via the hominin form in order to have fingers and thumbs as well as large brains to construct machines. Wouldn't the ET hypothesis from Earth-like planets be more likely than time-traveling descendants?
Well, I mean, there's some debate about that. I cite a study in my book from 4 or 5 years ago where I believe it was an astrobiologist, argued that life would trend toward a human form, and he made some arguments in that respect. If we look at the stochastic nature of evolution and just all of the different things that led to us at this present time, what if that asteroid hadn't hit the Earth 65 million years ago? What if mammals stayed underground because of our homeothermy? And there's countless things you could list that help contribute to our current state. And if there were other outcomes, we might not have looked the way we did, that we currently do, that we may in the future. And that's why I don't really discuss that in the book too much, is what might happen between now and then to make us look that way. It's mostly based on past trends, as I mentioned. As far as technology, I don't know. I think we could also have advanced technology with some other configuration. An octopus has 8 arms, but they might be able to make cooler things because of those extra arms. So I don't think that's necessarily a precursor, but definitely something to keep in mind.
Thank you. Even in 2021, we have basic technology to control genes and alter DNA. We can clone entire living beings. Parents may soon have control over their appearance of the newborns. People may even gain the ability to DNA modify their own appearance. Humans appreciate beauty in all things, and with general agreement. Why would, excuse me, that just jumped here. Why would the human race allow itself to evolve into a far less appealing form?
I don't know. I think they're kind of sexy, actually. The grays are hot, in my opinion. I mean, attractiveness is such a subjective thing. If you go to any culture around the world, people look very different from one another, and their notion of what attractiveness is changes considerably. Just look back over the last 100 years, even. We have body shapes and sizes and styles changing so much throughout that short period of time. So as we grow to change and evolve and look differently, I think we'll continue to be attracted to people of the opposite sex and continue to reproduce. But that aspect of CRISPR and gene manipulation, I think, is important to this conversation. It's very possible that something could go wrong in this process too. And I discussed this more in my next book. I mostly focused on that genetic homogenization aspect of it in the previous book, as I mentioned in the lecture. But in the future, if we did something wrong, if we tried to alter some aspect of our genome to save babies or to have more attractive appearances, and even if it was a somatic change where it was supposed to help us throughout growth and development to not contract the disease, but then that got into our gametes, if that became a heritable characteristic, it could have far-reaching effects that we don't yet understand. And this actually just happened in the case of a Chinese researcher who created the first genetically modified babies in an attempt to modify the CCR gene that helps protect you against HIV. And who knows what's going to happen to those babies? It's this natural experiment that went wrong. He went to jail for 3 years because it was unethical and violated a number of laws. But yeah, who knows? I think that gene modification aspect, I don't think we'll be able to avoid it. I think our desire to have either diseases that aren't present anymore or potentially more attractive individuals, sort of a Galactica, I forget the name of the movie, but I think that could potentially be an aspect of our future, whether positive or negative, time will tell.
There's a lot of experiencers that report humanoid gray beings that they encounter as having 4 fingers. Some have 6 fingers. Philip Corso talks about it in his book, saying that beings had 6 fingers, and apparently there were photographs of the craft's hand console and stuff like that that had 6. Can you comment on the evolution of hands? I mean, you talked about eyes and the head, but anything else?
Yeah. Pentadactyly, as I mentioned, that characteristic of 5 digits on each limb is a trait of tetrapods. So the 4 limbs and the 5 digits on each go together. However, with that said, if you look at the number of fingers on different animals, they've been repurposed over and over. You got the dew claw on a dog that's all the way down here. If you look at the limbs of whales and other sea mammals that went from sort of a dog-like creature to that of an ocean-dwelling creature, all of those bones changed in accordance with that new environmental selective pressure that goes along with using it for swimming as opposed to grabbing or walking. So yeah, it wouldn't surprise me. Even people now have 6 digits on each hand. There are those genetic mutations that take place in the same way that we could have isolation events, or as I mentioned, global inbreeding, incest, in association with this homogenization of our genome. If there were certain traits where we had more fingers or fewer fingers, and those started to move through the population, they could potentially reach fixity. But because most reports do describe pentadactyl characteristics, I don't know if that's likely to happen, but it could be an aspect of the variation.
Okay. In a lot of the previous presentations, like that others say in the conference, that we cannot travel back in time to the past, and the time machine was turned on until the time machine was turned on. Assuming that we don't currently have a time machine, how do you account for that in your hypothesis?
Yeah, I remember reading that in Paul Davies' book about time, I think when I was in high school, actually. And it's definitely something important to consider if that is an aspect that limits our ability to go back into the deep past. And arguably, we don't yet have a time machine, but we do still see these beings and the craft, which I argue have that ability to manipulate space-time. And from Hal Puthoff's lecture yesterday and many others, they clearly have the ability to warp space-time. Time travel in the future is very easy. We haven't yet figured out time travel to the past. I sort of, it's hard to know. Obviously, nobody knows really even how we address this issue of backward time travel. In my book, I talk more historically about what we've learned since 1915 and Einstein's paper on general relativity and the field equations he published in association with that, and how a lot of the solutions to these field equations, since Lenz and Thüring, Van Stockham, Gödel, Tipler with the Tipler cylinders, the commonality is that you have the rotation of a massive or highly energetic ring, sphere, in many cases disk, such as the case with Tipler and his Tipler cylinders. If you compress that down to a finite size and it has the right rotational energy and the right mass and energy, that you can create these closed time-like curves. So with regard to this question, if you are able to locally manipulate space-time, you're still going forward in your local reference frame, but you're moving into the global past. I find it hard, just from a logical standpoint, to think that your time machine, as it's moving into the past, would somehow know that you've just reached that point when the first time machine was created and suddenly break apart into all of its components. So I think, that it's something that needs to be considered. I have a feeling that it's incorrect, and we can look at the numbers, we can look at the calculations, but really until we understand time, not as an emergent phenomenon, but as something fundamental in our universe, until we understand quantum gravity, I think it's going to be difficult to really know either way.
Sure. What would be the time frame before we evolve into something like the tall grays?
Something like the tall grays, I really try to avoid talking about this or speculating about this in my book. I got forced to do it, kind of put on the spot on Coast to Coast by George Norrie once. And gave a number, so I should probably do the same here. But I think it's important in the context of this temporal ancestry, and as I acknowledged in the lecture, that we could be talking about these humans, the ones I talk about a number of cases in my next book, but many who are described as human that aren't speaking telepathically, but they're using vocalized speech. It seems to indicate that we may crack the code on time and time travel sooner than we might think. Because again, based on the Dr. Edgar Mitchell study, most are human. But yeah, once we get to those tall grays, the short grays, that seems to indicate that if this theory is correct, and again, there's many other theories, and I certainly think we should acknowledge those and consider all of the evidence in the context of these theories as well. But based on those physical traits and based on the acceleration of our traits into the future, I think we're looking at possibly 8 to 15, possibly 25,000 years before we start to get those characteristics. If we are modifying our genome, that could happen faster. It's really hard to tell what the future holds.
What level of evidence would your discipline of study require to bring you the hypothesis that you're presenting beyond a hypothesis or theory that and become a form of evidentiary scientific study?
Yeah, that's a great question. I need a body. If anybody has an alien body laying around, I would pay top dollar to see that bad boy. Because yeah, I mean, we get these craft, we get these videos. You guys at the SCU did an awesome job breaking down the Tic Tac, the Aguadilla, and we don't have that in biological anthropology. And maybe somebody has it. Maybe this crash retrievals have actually, gotten hold of the physical form of these beings. And I think that's what it would take within my discipline of biological anthropology to really be able to bring this to the forefront and talk about it in real terms. And I acknowledge that even before started the presentation and in the presentation, that it is a more tenuous aspect of this argument because we don't yet have that. I don't have access to it, at least.
Your theory answers the question regarding why certain ET species, if you would, look like us, a number of the reports. However, many reports from credible experiences also talk about various other species, things like nothing like hominins, reptilians and insects and all this other kind of stuff.
Yeah.
What does your theory account for the possible development of known terrestrial reptiles or insects or sentient beings or anything of that nature?
Yeah, as I mentioned in the talk, I know we're running short on time, so I'll try to keep this brief. But yeah, I mean, I was talking to Whitley Strieber about this once, and he proposed what I mentioned earlier, that that post-human world, that maybe reptiles, insects who clearly have staying power on this planet, as indicated by their longevity that predates anything mammalian by hundreds of millions of years. If we do get to the point where we are annihilated and they take over, they become sentient, conscious beings with high technology, and maybe I don't know if I necessarily subscribe to that. I threw it out there because I think it's interesting to consider. But yeah, potentially there's a post-human future that we're not a part of, and some of these beings who we don't see as often, that could account for the 5%, because the farther you get from our current period in time, you have the sampling error issue. And I'll wrap this up. It's the last thing I'll say. But in the same way that when we go back archaeologically, the farther back in time we get, the fewer things we find. So we expect to see more human-like individuals if they're closer to us in time, fewer from farther away, and that could help explain that low level of variance in the insectoid and reptilian reports.
If you get a chance, I know we're running out of time. If you can, there's a lot of questions over there, and get a chance to answer some of those directly in the system, that would be absolutely fantastic.
Yeah, and you just go through chat for that, is that right? Or is it the Q&A part?
It's the Q&A part right there on your session, but please feel free to address those. And I guess what we're moving into, and again, thank you
thank you, absolutely. I appreciate this conference, this conversation. It's awesome. Appreciate everything you've done.
Well, thank you again. I appreciate you being a part of it. We're going into a break right now. It's roughly about 12:31. I'm seeing right now. We're a little 5 minutes in. So if you would, during the course of the break, take a look at that other video that I mentioned. We're going to be coming back in an hour or so. And I'll be able to do that briefer. So let's go with 1 hour from now. We'll be back into the session. That'll be Dr. Silvano Colombano. Thank you so much again, and I'll be stopping the session here in Zoom.